Okay, so we have two more conic sections that we need to talk about. The first one is the ellipse and the next one is the circle. Now these two are related in that a circle is actually a special type of ellipse. Okay, so their formulas are quite similar. Now with an ellipse you have this. Okay, now with an ellipse, the standard form of its equation looks like this. The a squared plus y squared over b squared, and this is equal to 1. Okay, so it is always equal to 1. If you get the equation and you don't have 1 on the other side, you have to divide by whatever you have on the right hand side to make it equal to 1. Here a and b are constants, and this is what an ellipse looks like. So you have your x and y axis over there, and then this sort of looks like a squished circle, even though a circle is an ellipse actually. So this is minus a, and this is a. Here I have minus b, over there I have b. Now with an ellipse you have what is called the foci. Now these are 2 points over here. Now these 2 points, they are important in the sense that they are the ones that make up the shape of an ellipse. So if you were to measure the distance, let's say somebody is standing here, another person is standing there, then you measure the distance to the ellipse, that's the first person, and that's the second person, and then you add them together. You will notice that it doesn't matter where on the ellipse you stand, the distance will always, or the sum of the two distances will always be the same. So somebody else who is standing here, if I take their distance there and then this one's distance over there, and I add the two together, you will see it is the same as the one in red. So we say that an ellipse is the locus of the points on a plane whose sum is fixed. The sum of the two distances is fixed. Okay, so that's what an ellipse is. So when you sketch this, I want to see the x and y axis drawn clearly. I want to see a and b labeled clearly, and that's pretty much it. Okay, so we can look at an example of an ellipse. Let's see. Okay, number 15 in your book on page 104, we have 3y squared minus, we have 3y squared minus 27 is equal to negative 9 squared. Okay, somebody is trying to join the meeting. Let me just admit them. Okay, so this is the question we have, and when you're given any equation, you should be able to identify, say whether this is a line, a circle, an ellipse, and so on. Okay, so here I will rewrite this in standard form. That means x and y on one side. So I will have 9x squared plus 3y squared, and this is equal to 27. Now remember, in standard form I need this to be equal to 1. So what I do is I will divide by 27 throughout. Divide by 27. Divide by 27. So I have x squared over 3. This is equal to, sorry, not equal to, plus y squared over 9, and then this is equal to 1. And then just to write it in standard form, I have x squared over the square root of 3 squared, because I must have x squared over a squared. So square root of 3 is my a, and then plus y squared over 3 squared. So the only difference between an ellipse and hyperbola is the sign over here. If I change the sign to minus, then I have a hyperbola, but as it is, this is an ellipse. Then the sketch is very simple. This is your x and y axis, so that's my x and y. I label it. We say that a is on the x-axis, so I have minus square root of 3, and then square root of 3 over here, and then 3 here, and then 3 over there. And then you join the points like that, so it should be smooth. So on your graph it'll look better, but it should be like that. It should be a vertical, because the y-axis is longer than the x-axis, so it's not like that. So it's not horizontal, it's more vertical, because over here I have 3 and minus 3, and then this is square root of 3, which is smaller, so it looks more vertical than it does horizontal. And then that's it. You just label it. So you say x squared over the square root of 3 squared plus y squared over 3 squared, and then this is equal to 1. So drawing an ellipse is pretty simple, nothing much to do there. Then the circle, like I said, the circle is just an ellipse where a and b are equal to 1. Because with an ellipse, let's start, this is a circle. With the ellipse, you have x squared over a squared plus y squared over b squared, and this is equal to 1. Now when a and b are equal to 1, then what you have is just this. This is x squared plus y squared, and this is equal to 1. This is a circle with a radius equal to 1. Now the general formula of a circle looks like this. You say x minus a squared plus y minus b squared, and this is equal to r squared. So you will try and write it in this form. The reason we do this is because this circle has a center at a comma b, so the a coordinate, the b coordinate, that forms your center, and then the radius of the circle is just equal to r that I have over there. Okay, so if your equation is not given in this form, you must first rewrite it in standard form, and then from there you can say this is what my center is, and then you can tell what your radius is. Okay, look at example. We have 2x squared plus 2y squared minus 12x plus 8y minus 6 is equal to 0. This is equal to 0. Now here, what you will have to do to write it in standard form is you must complete the square. So you're going to complete the square for x and then also complete the square for y. and then you'll have it in standard form. So to do that, I will look at the two terms of x together. So it's this 2x and minus 12x. I can factor 2 out. So I have 2x squared minus 6 squared. And then the y terms, I have 2y and 8y. And if I factor out 2, I have y squared plus 4, and then this is just equal to the 6, so I can take the 6 to the other side. Now I complete the square. I hope you remember how to do that. I have 2, this bracket, I have x minus 3 squared minus 9. That's completing the square on x. Then I do the same thing with y. This 2 should remain outside. And then I have y plus 2 squared minus 2. Okay, and then this is all equal to 6. So that is how we complete the square. Then I'll multiply the 2's that are outside the square brackets. So I have 2x minus 3 squared, and then minus 18 and do the same thing with the other one. So I have plus 2. Let me just this. Okay, so I have 2y plus 2 squared minus 4, and this is all equal to 6. So let me just check. I think I've multiplied it out correctly. That's fine. Then I will take the minus 18 and the minus 4. When I combine them, I get minus 22, which I will then have to take to the other side. So I have 2x minus 3 squared plus 2y plus 2 squared. Then we say the minus 22 goes to the other side, and when it does, I think I get, how much is that? 8, not 18 minus 2, 16. I need a calculator. Okay. Yeah, I think it's 16. Okay, minus 16. Okay, then that's not right. I have to add them. So I have 22 plus 6, which is 28. Okay, because they're both negative. When they go to the other side, they should become positive. Then I will divide both sides by 2. So I have x minus 3 squared plus y plus 2 squared, and then this is equal to 14. Okay. I think I need to see if my calculations are correct. Let's just go back and see. 2, okay, factor out 6x. It should be a 6x. An x missing there. There's an x missing there, so that's fine. Then divide by 3 squared, that's fine. Okay, that's factorized. That's the square is completed correctly. And then multiply out the brackets. That looks fine. Minus 4, and that is 22. I am getting 28. Okay, my calculations seem fine, but that is different from what is in the book. X minus 3, y plus 2, and 6 Anyway, so here I would have to write it like this. Plus y plus 2 squared, and this is equal to the square root of 7, which is squared. So your center will be, the center will be 3 and then negative 2. The reason I have negative 2 is you'll say y plus 2 is equal to 0, and then what you do is you solve for y, you get y is minus 2, and then here I'm getting a radius of square root of 7. So you can check my calculations and see what I did wrong or why it's different from the ones in the book. Maybe I didn't copy the question down correctly. Minus plus 8y minus 6 is 0. Then 2, yeah. Let me just write this nicely. X, okay. That is 4x, okay. Okay, we have 6 and 4, that is fine. Okay, I cannot see what is wrong, but check it later. Then to draw the circle, you would just do that, your x and y axis, go to the center, which is 3 minus 2. So 3 minus 2 is somewhere over here, and you must label it. This is 3, and then minus 2 will be over there. Then you also need to work out your intercepts as usual. So your intercepts, this is, to start with the first one, when x is equal to 0. Now if x is equal to 0, when I substitute it over there, if I look at what I have there, what you do is you substitute x is equal to 0 in your equation, and then you solve for y. So I'll substitute it in the original equation. I will have 2y squared plus 8y minus 6 is equal to 0. So this is a quadratic equation. You'll have two solutions because I'm sure you can imagine a circle. You draw a circle, it'll cut the y-axis at 2 points. So you divide by 2 throughout. So you have y squared plus 4y minus 3. This is equal to 0. And looking for two numbers, you multiply them, the answer is negative 3, and when you add them, the answer is 4. That doesn't seem like it can be factorized. No, it cannot be factorized. So what you do is you can use the quadratic formula, or you can complete the square, which we have done over here. So you will have this formula over here. You can use it, substitute x is equal to 0 there, and then you'll get your value of y because we've completed the square for y there. So I have 0 minus 3 squared, and this is equal to plus y plus 2 squared, and this is equal to this should be square root of 14. This is just equal to 14 because the square root of 14 squared is just 14. Then I have 9 plus y plus 2 squared. This is equal to 14. Take the 9 to the other side. I have y plus 2 squared. This is equal to 14 minus 9, which is 5. And then square root y is equal to negative 2 plus or minus the square root of 5. Okay, square root of 5 is 2 point something. So your values are going to be negative 4 point something and 0 point something. Okay, so you can work that out. So one will be maybe somewhere there, and the other one will be somewhere down over there. Okay, so you can see it's going to go, maybe cut it somewhere there, come back, cut the y-axis again over there, and then cut the y-axis, the x-axis over there. And to get the x-intercepts, we say y is equal to 0. So we'll do the same thing. If y is equal to 0, we have x minus 3 squared plus 0 plus 2 squared. This is equal to 14. Then you solve this. This is x minus 3 squared, and this is equal to 2 squared, that is 4. Then 14 minus 4, this is 10. Then x minus 3, this is equal to plus or minus the square root of 10. And then I have x is equal to 3 plus or minus the square root of 10. So square root of 10 is 3 point something. So the first one will be negative 0 point something, and then the second one will be 6 point something. So you can work that out, and you will see that this is 0 point something. It's very small, and then the other one is 6 point something. Then what you do is you take your compass, and then you connect all the points to there, and you open your compass so that the radius is the square root of 14 units. So it should look like a nice smooth curve, and then all of these should be labeled. So this one over here, we say this is negative, okay, we say it's negative 2 plus the square root of 5. Okay, which is a positive number. And then that is, let me just see what I did. Then the second one was negative 2 minus the square root of 5. Then this one is, and the x-intercepts, just need to label them, 3 plus root 10. Okay, so this is 3 plus the square root of 10, and then 3 minus the square root of 10, which is negative. And then that's it. And then your center, of course, must be labeled. Either you draw the dots like I have done over there, or you write it like that. So this is minus 2, 3. And then it should be a nice smooth circle. So I need to see the x and y axis labeled. The center must be clearly labeled. The x and y intercepts also labeled. Then you can tell me that the radius is, what was our radius? Square root of 14. Okay, that's it. Right, so now looking at the exercises on exercise 9.5, those sketches will just be everything that we have done, either a line, hyperbola, parabola, ellipse, or a circle. So you just have to identify what it is and then sketch it. So it's important to show all the critical points, and then that's it. So let's look at those ones. We identified a number of them yesterday. So we start with number one. Number one. With number one, we have y is equal to 2x over 3 plus 1. Now we say that this is a straight line, and with a straight line, if you know the intercept, the y-intercept, you can use the gradient to work to draw the line. So if I were to do that, this is what I would draw. This is my x-axis, and that is my y-axis. So I plot the y-intercept, which is 1. So I'll put 1 over there. Then I said what I'm going to do is use the gradient. Now the gradient is 2 over 3. That means the change in the y is 2 units up because it's positive. So I'll move 2 units, 1, 2, and then I will end up at 3. So this will be a 3. So my scale is not very accurate, but understand the steps. So I end up at 3. And then in the x, the change in the x is 3. That's positive. That means I must move 3 units in the positive direction. So I'm here, then I go 1, 2, 3. So this is 1, 2, 3. This number will be 3 over there. So this is the point that I have there. And what I do is I take my ruler and then I just connect the 2 points. So there, like that. And then you connect it until you get to the x-intercept as well. So you need to label what your x-intercept will be. And that's it. So you can see it has a positive inclination. Now when you're drawing it on your paper, it will be easier. You can extend it. So that's one way. The other way to do it is to find both intercepts and then just connect them. So I already have the y-intercept given to me. It's 1. Then to get the x-intercept, I say y is equal to 0. Then I will solve it. If y is equal to 0, I have negative 3 over 2. So negative 3 over 2. Yeah, negative 3 over 2 will be somewhere over there on the other side. I cannot draw. But that is how to draw the line. So you have to show your x and y axis, label the line, 2 over 3, x plus 1. And then on this side, show your x-intercept. Here, it's enough that you've drawn the 1 there to show that that is the intercept. Then number 2 is also a straight line. So you do it in the same way. Either find both intercepts and then connect them with a line. Make sure they're clearly labeled. Have your x and y axis clearly shown. Number 3 is also a straight line. So you do it in the same way. Number 4 is also a straight line. Now number 5. Number 5 is a parabola. That's the example we did yesterday. Number 6 is also a parabola, but we can do that one. We have y is equal to negative 2 over 3x squared. So remember, with a parabola, first thing you should decide is does it open upwards or downwards? Here the coefficient of x squared is negative, so it opens downwards. Then you have to work out your intercepts and then the turning point. Okay, just hold on. Okay, so we see that it opens downwards. We just need our intercepts. Now we start when y is equal to 0. Now when y is equal to 0, we will have 0 is equal to minus 2 over 3 x squared. And this just means that x is equal to 0. Okay, and then when x is equal to 0, then obviously y is equal to 0 because we get it from over there. So the x-intercept and the y-intercept are the same, so it has only one x-intercept. Then the turning point, we said you have to complete the square. So here, if I were to complete the square, this is what it would look like. Minus 2 over 3 x minus 0 squared plus 0. So from here, I can tell that my turning point is at the origin. And also, in general, when you have one x-intercept, it usually means that that x-intercept is your turning point. So we have everything we need. We have the turning point, we have the x and y intercept, we know which direction it faces. The only thing left is now to just sketch it. So this is x-axis, that is my y-axis, and then my graph will look like that. So here, this is 0, obviously, and this is y is equal to minus 2 over 3 x squared, and that's it. So with this graph there isn't much to show, and then you are done. Then number 7 is also a parabola. You can quickly do that one. We have y minus x minus 3 squared minus 2. Okay, this is equal to 0. Okay, so I can just rewrite it as y is equal to x minus 3 squared plus 2. Okay, this is already in the form where the square is complete. So I can already read what my turning point is. So my turning point will be negative, positive 3. Will be 3 and then 2. That is my turning point. So I read this, I solve this equation, x minus 3 is equal to 0. That means x is equal to 3. And then this 2 over here. Because when I substitute x is equal to 3 there, I will get positive 2. So that is my turning point. Then my intercepts. We have x is equal to 0. So when x is equal to 0, I have y.
Sorry?
Yeah.
How did you get turning point again? I get lost there.
With the turning point, you need to complete the square. So you see, when it's in this form, the square is complete. Then you just read the coordinates from this one. You say x minus 3 is equal to 0. Then you get x is equal to 3. That's the x coordinate. Then if I substitute 3 over there, the answer is just that 2 there. That is where this 2 comes from.
Okay. Okay, thank
Yeah.
you.
And then, yeah, so y
Use the
is
other
equal
formula.
to, sorry,
For the
say that
turning
again.
point, can I also use the other formula?
Yes, you can use minus b over 2a. That is also fine.
Amen.
All right. Then I substitute 0 there. So I get 0 minus 3 squared plus 2. So this is 9 plus 2. This means that y is equal to 11. And then the second one, we say y is equal to 0. Then I have 0 is equal to x minus 3 squared plus 2. And then here you'll see something interesting. X minus 3 squared is equal to minus 2. Now you're squaring something and the answer is negative. That is not possible. So this one here has no solution. Now what that means when a parabola does not have an x-intercept means it either fully lies above the x-axis or fully below. So it'll be something like this, or it is something like that. So you can see in both cases the parabola does not have an x-intercept. Okay, so we have everything we need. We have the turning point, and we didn't say what shape it has. Here the coefficient is 1. 1 is positive. That means it is going to open upwards. So I will draw this like that. So I have a parabola that opens upwards. The turning point is at 3, 2. So that's 3. And 2 is over there. So there it is. So I can draw my dots just to show that that is the coordinates. And then we say the y-intercept is at 11. And 11 will be somewhere up there. And then I will draw nice smooth parabola like that. This is 11. And then I will label it y is equal to x minus 3 squared. What was it? Plus 2? Yeah, plus 2. Like that. That is a 2. Yeah.
So when labeling, you have to use the simplified equation, which is also the standard form. Or do you label the original one?
No, it doesn't actually matter which one you choose to label with. I'm just using this one because I didn't write it in any other form. So if I had multiplied out the brackets and then wrote it in standard form, I can label it like that. It's fine. As long as there is a label, then your x and y axis should also be labeled. Okay? So that's pretty much all I want to see with that one. And then we were on number 7. Number 8 is also parabola. For that one, I'll just complete the square, and then you should be able to see how to sketch it. So number 8, we have 2y. This is equal to x squared minus 3x plus 6. So what you'll do is you divide by 2 throughout. 8x squared minus 3x. Okay, so you have y. This is equal to a half x squared minus 3 over 2 x plus 3. And then you can complete the square. Y, this is the half. You factor it out. You have x squared minus 3x plus 3. And then the half remains outside the square brackets. So I have x minus 3 over 2 squared minus 9 over 4 and then plus 3. So this is a half x minus 3 over 2 squared. And then I have minus 9 over 2 plus 3. And this is just a half x minus 3 over 2 squared. And then 9 over 2 is 4.5 plus 3, that's 7. Oh, no. 9 over 2 is 4.5. Negative plus 3. I should end up with negative 3 over 2. So here you can say that your turning point will be 3 over 2. So the half doesn't affect the turning point in any way. You just look at this that you have there, equate it to 0 and then solve. And then your turning point is that one. So it's negative 3 over 2. Then the intercepts, you work them out in the same way. And then you sketch it. Okay. Then number 9. Number 9 is a circle. So let's look at that one. We have x squared plus y squared. This is equal to 49. So in standard form, we write it as x squared plus y squared. This is equal to 7 squared. So this circle has a center at the origin, 0, 0, and it has a radius of 7 units. Now the only thing we need to find out is what are the intercepts. So first you make x 0. So for my intercepts, we make x 0. Now this, very simple, if x is 0 over there, it means y squared is equal to 49. Y squared is 49. This means that y is plus or minus 7. And then the same thing will be true when y is equal to 0. So when y is equal to 0, this means that x squared is equal to 49. And this means that x is equal to plus or minus 7. Then, now you sketch because you have everything. You have the intercepts, you have the center, you know what the radius is. So you take my axis. So I have 7 here. This will be 7. That is minus 7. I have 7 there. And then I have minus 7 over there. And then this is my center. You take your compass and then you connect these points with a nice smooth circle. The compass, yeah, that does not look like a circle. Okay, so that is the best I could do. So that's that point there, 7. And then can label the origin, but the origin is not necessary to label it. I must see the x and y axis labeled. And this is x squared plus y squared. This is equal to 49. And that's it. Okay, so I need to see x and y axis labeled, the graph itself labeled, the center labeled, and that's it, with the intercepts as well. Then number 10, let's see number 10. With number 10, sorry?
It's not also a circle.
This is a circle, yes. It just doesn't look like a circle because I'm drawing it here, but I said you take your protractor and you connect all the points. So this is a circle. See, that's, see it over here. It has a center, where is that? It has a center and the radius, that's a circle. Oh, are you talking about number 10? Maybe I didn't get what you were saying.
Yes,
Number
I'm talking
10.
about. Yes, I'm talking
Number
about number
10.
10.
Oh, sorry. Okay, let's see. We have 3x squared plus 3y squared. This is equal to 48. So here, I don't think it is going to be a circle because what we do, okay, no, it is. Can divide by 3 both sides. Anyway, divide by 3, divide by 3. Then we divide by 3, we get x squared plus y squared. This 48 divided by 3, what does that give us? What does that give us?
16.
The 16. Okay, so you
Yes,
get
ma'am.
16. So this is a perfect circle. So y squared, this is equal to 4 squared. Okay, so this is similar to the other one. The center is at the origin. The radius is 4. And then you just sketch it like the one we did previously. So this is a circle. It has radius 4 units, and the center is at the origin. Okay, then number 11, we have
Also a
y
circle.
is equal. Okay, he says it's also a circle. This is 16 minus x squared. You can square both sides.
Web.
Now this is a, yeah, this is actually a particular circle. So when you see this one, it is actually just the top half of the circle. If it had a plus or minus, then it's the entire circle. But because it's just the positive square root, this is just a semicircle. So what you will do is you can write it in standard form. You square both sides. This is 16 minus x squared. And then you have x squared plus y squared is equal to 16. But when you sketch it, you will only draw the top half like that. So this goes from minus 4 to 4. So that's your x-axis. That is your y-axis. And then this point over there is also equal to 4. So again, the reason why this is a semicircle is because you only want the positive, you only want you you only want the positive square root of that. Okay, the bottom one. So in a test, if you have this y is equal to negative square root of 16 minus x squared, this is the bottom half of the circle. So square root is a semicircle. Only when it's plus or minus do you draw the entire circle. Okay. Then number 12. We have y is equal to 3 over 2 square root of 4 minus x squared. Okay, now this one looks like it is some kind of semicircle-ish. So what we can do is we can multiply both sides by 2 over 3. So I have 2 over 3y, and this is equal to the square root of 4 minus x squared. Okay, then when I square both sides, I have 4 over 9 y squared, and this is equal to 4 minus x squared. And then what you will have is x squared plus 4 over 9 y squared. This is equal to 4. Then I can divide by 4 throughout. I have x squared over 4 plus y squared over 9. This is equal to 1. Now when it's in this form, you can see that this is actually an ellipse. Okay, because I can rewrite it. It's x squared over 2 squared plus y squared over 3 squared. This is equal to 1. But then I go back to my equation where I wanted the positive square root. So you'll only draw, yes? Was there a question? Did you have a question? Okay, so going back to the question over here, we look at square root. So you'll only draw the positive part of your ellipse. So this is an ellipse, but I don't want both parts of the ellipse. I want only the positive part of the ellipse. Okay, so you can sketch that one. So you find your intercepts the same way that we do.
Jumping on the bed.
So your intercepts. My goodness. Okay, so the intercepts. You can say x is equal to 0, y is equal to 0. You ignore the negative ones because the square root there is positive, or the coefficient of the square root there is positive. So we start when x is equal to 0. This means that y is equal to 3. So this means that y is equal to 3. And then, so I'm substituting into this equation over there. I put x is equal to 0. Then I have y squared is equal to 3 squared. And then y is just equal to 3. The reason I'm only taking the positive one is because of the question. In the question, this square root is positive. So I only want the positive one. I do the same thing when y is equal to 0. So when y is equal to 0, this means that x is equal to 2. Okay, so then I will go and sketch it. So normally my ellipse will look like this. So normally this is what an ellipse would look. It will look like this. This is what it will look like. This value here is minus a. This one is a. This is b. And that is minus b. That is how I would draw the ellipse. But this time I want only the positive part because of the square root again. So I will do everything in the same way. I put that will be x, and that will be y. So minus a, so I go back my equation over here, a is 2. So here I have minus 2, and there I have 2. And then my b is 3, so I have minus 3 here, which I'm not going to use, and then I have 3 over there. Then we say that the x-intercept, we have 0, 3. That's this one here. And the y-intercept is that. So what I do is I just connect them like that. So I only want the positive part of this curve there. And that's what I have. Okay, do we have any questions about this?
I actually have a question.
Yes.
I don't know how to say it. It's 4. I don't know if it's 4 cubed. So
Sorry, I can't hear you.
oh, miss, I don't know how to say this. When the root is a 4 and not a 2. I don't know how to say this.
When the root has a 4 and not a 2, what does that mean?
Yeah. And it's like, I don't know, it's quad or something like this.
The fourth root.
Yeah, the fourth root. Yeah. Is it, then
What a,
it means that like a certain part, like if that was like the case, then the question was given, then it was like having something.
I can't actually hear what you're saying. I'd have to see what question you are talking about, and then maybe then I could understand.
I'll take an example, like the WhatsApp.
Say that again?
I'll take send it on the WhatsApp.
Okay, then I'll look at that one. Okay, there any other questions? Okay, if not, I will post this later today. I have a packed schedule, but before the end of the day tonight, I will post this on YouTube and then send you guys the link. Okay, tomorrow we have a class at 7:30, so I will see you then.